Hello, geometry, and welcome to Unit 10, where we will be dealing with circles the whole time. So this whole unit is based on circles. So here we go. The first two lessons deal with arc length and area of a circle, and then we start getting into some of the more intricate stuff later in the unit. All right, so identifying and finding measures of minor arcs, major arcs, and semicircles, and then finding the length of a given arc. All right, so this circle has as its center, has its center at point O. Nothing tricky there. Therefore, we can name this circle, which is a dot with a circle around it, O. That looks really weird, but a lot of times, let's say this was like a P in there. You would say circle P. Okay. I'm not going to call it circle P because the rest of the notes refer to this circle as circle O. Each line segment from the center to the circle is called a radius. You might have heard that before. You probably have. Those are each called a radius. Plural it's radii. Each of these line segments have congruent lengths. All radii in one circle are congruent. A line segment that goes through the center and has both endpoints on the circle is called a diameter. Probably have heard that one as well. This line segment, the diameter, is double the length of the radius because it's two radii put together. All right. The distance around the outside of a circle is called the circumference. Think of it as like perimeter. The perimeter of a circle is called the circumference. We're going to be dealing with circumference in this lesson. The next lesson, we're going to be dealing with area. The formula for finding the circumference is 2 pi r. All right. One thing I want to make sure I point out right now, I'm going to change colors here. I do not want you using 3.14 for pi. All right. Don't do that. That's a middle school concept. We're not doing that in this class. So pi is not 3.14. It's close to it, but it's not 3.14. All right. Now arcs. An arc is a portion of the circle around the outside. An arc can be a minor arc, which means its measure is less than 180 degrees. An arc can be a major arc, which means its measure is between 180 and 360. But it cannot equal 180. An arc that measures exactly 180 degrees is called a semicircle or a half circle. All right. The measure of an arc is determined by the arc's corresponding central angle. We are going to have many different types of angles in this unit. The central angle is the first of those. I will just give you a heads up. We're going to be dealing with inscribed angles. We're going to be dealing with angles that are that just happen in the circle somewhere, but not at the center. Right, so we're going to have a lot of different angles going on here. Make sure you look at the relationships with these angles. All right, so this one's pretty easy. For example, BC, arc BC, which is this arc up here. Look at the circle that I'm drawing on. That's the arc BC. It's made by the radii CO and BO. Give it like a slice of pie or pizza, right? The corresponding central angle is angle COB. And the measure, that's what the M means, the measure of arc BC is 57 degrees. Furthermore, BC is classified as a minor arc because it's less than 180. Right? The relationship I want you to see here is that the central angle equals the intercepted arc. And you'll hear me say intercepted arc a lot. Okay. I'm going to go ahead and erase the circle. I'm going to go back to the circle here. I'm going to redo basically what I just said. The central angle, this is that 57-degree angle there. It intercepts the circle here and here. So the intercepted arc is the connection of those two things. So the intercepted arc in this case is 57 degrees because it matches the measure of the central angle. Okay, I need that picture of the circle. So I'm going to go ahead and clear everything. I need the picture of the circle, but I'm going to go down real quick and just look at the bold part. Minor arcs are named with 2 letters. This is big. If you give me 2 letters, you're looking at a minor arc. Semicircles and major arcs are named with 3 letters. You gotta see that difference. Okay, so I'm going to scroll back up. So you're not going to see this part here on the video, but you have it in your notes. So fill it in as I go over it, because I need to go back up to the circle. So we're going to name 4 other minor arcs. We're going to name 3 semicircles, and we're going to name 3 major arcs. So we're going to clear that real quick and scroll back up. So the minor arcs goes here. I said 4 other minor arcs. Well, I've already named arc BC, right? So we're going to do 4 other ones. These are usually the easier ones. CD is 1. Okay. DE is another. Notice it's 2 letters. Minor arcs are 2 letters. EA is another. Oops. And AB is another. Those are all less than 180. Now you're looking at EA and AB, and you're thinking, how do I know? Well, it goes kind of with what I'm about to show you here. With the semicircles. Okay, so name 3 semicircles. So I look at a diameter. So I see a diameter here, EB, right? That's a diameter. A semicircle is going to start at E or start at B and end at the other one. So E all the way around to B. And that's exactly 180 degrees because it's a diameter, right? So I could say arc EAB. All right. If I say BAE, it's the same semicircle, so I don't want to say BAE. That's not a different semicircle. Another semicircle would be going the other way. So EDC, right? That's going this way. The middle letter tells you the direction. All right, so E starts at E, or sorry, not C. Back up. Not EDC, EDB. That's what I meant to, right? EDB. The middle letter tells you the direction. The first letter tells you where to start, last letter tells you where to end, and the middle letter tells you the direction to go. All right. I could name that same semicircle ECB. Those are the same. They are not different semicircles because they're starting at E and ending at B and have the middle letter in the same direction as D. Okay. I made a mistake a little bit ago, but I want to show you a little bit back over here to minor arcs. I said EDC. A lot of people think that that's naming a minor arc. It is a minor arc, EDC, but we don't use 3 letters to name a minor arc. So that would not be counted correct because that's 3 letters names a major arc or a semicircle. All right, now major arcs. Those are more than 180. All right, so before I do the major arcs, we'll go back to semicircles here real quick and show you that if I know that that's 180, then I know that this angle here and this angle here have to be less than 180. So that's how I knew that EA was a minor arc and AB was a minor arc, because they have to be less than 180. I could find out what those measures are by doing some math, but we're going to do that more on the back. Anyway, let's go to major arcs. Major arcs, you got lots of them. There's not 3 of them here. There's a lot more than 3. I'm going to start at E, and I'm going to go around past B and stop at A. I could name that arc 3 different ways. I could actually 3 different ways. Arc E, D, and I stop at A. Another way to name that same one would be ECA or EBA. Another major arc. So I'm not going to start at E this time. Let's start at D. I could go all the way around this circle and stop at E. So arc D, A, E is another major arc. And then again, there's lots of them here. I could say D or C, and then go the other way. D, not circling it there. C, E, and I could stop at B. So arc C, E, B. That's just 3. There's probably more. All right. All right, to the backside. I know I spent a lot of time there on the front, but this stuff is all hugely important to move on with this unit. Okay. Use circle Q to answer the following questions. Find the value of X. So when we look at this, like, how do I do that? Well, I see LP is a diameter, right? I know that that equals 180 degrees. Okay, so I'm going to add up 2x plus 3, 3x plus 5, and 4x plus 1. And since those all 3 of those angles come together to make line LP, I know they add up to 180 degrees. So combine like terms here. I'll go quickly. You got 9x. 3 plus 5 plus 1 is 9 equals 180. Subtract 9, I get 9x equals 171. And I get x equals 19. All right, now what are we going to do with that? I'm going to plug those in. I'm going to plug 19 in, and I get, let's see here. Grab my calculator. 2 times 19 is 38, plus 3 is 41. So this angle here is 41 degrees. 3 times 19 plus 5 is 62. I know they're not drawn to scale. I get that. And then the last one is 4 times 19 plus 1 is 77. Now, find NP. Well, I just kind of marked it there. That's 77 degrees. Now, that's arc NP. But that's equal to the central angle, which we just found was 77. Find the measure of arc LK. So that one doesn't have anything marked. How do I do that? Right? Well, I see vertical angles here. Do you see how we're using stuff we learned in first semester? Vertical angles are equal. So this is 77 as well, which means the arc is 77. And the measure of PK. Again, there's nothing there. There's a couple different things you could do. I'm going to go ahead and erase my stuff here because I'm going to show you what's happening. I see that KN is a diameter. That's 180 degrees. This part's 77. What's left to finish the semicircle? Well, that's 180 minus 77, which is 103. LMK, I'm using 3 letters this time, meaning it's either a semicircle or it is a major arc. So LMK, so I start at L, go towards M, but past it and stop at K. Now, could you add up all 4 of those angles? You could. We know them all. You could just add them up. Or you know that a full circle has 360 degrees. And you know that LK, we already found that was 77. If you subtract that, you're going to get the measure of that arc. So the full circle minus that little piece, 360 minus 77, I get 283 degrees. All right. So that's finding arc measure. Arc length is slightly different. The measure of an arc and an arc's length are 2 different things. The arc length depends on the length of the radius. Notice how what we just got done doing, there was no measurement other than angles that we dealt with. There was no length involved. It was just measures of angles. Now we have to take into account the radius. The arc length is a fraction of the circumference. So remember, we talked about circumference at the beginning. It's the distance around the outside. So fraction of the circumference. So that leads us to the formula. So the circumference is 2 pi r, right? But we're only doing a portion of it, a fraction of it. And the way we figure out the fraction is the measure of the indicated arc. So I'm just going to put AB to stand for all types of arcs out of how many degrees possible. So that's the fraction piece. And you just multiply it by the circumference and you've got the arc length. So we're going to do a couple examples here. So find the measure of arc AB. That should be pretty easy. The central angle is 45 degrees, so the measure of the arc is also 45 degrees. Find the length of AB. So the length now, we're talking 45 degrees out of the 360 total in a circle. But then we got to multiply it by 2 pi r. And the radius here is 12. Now it says leave your answer in terms of pi. I'll talk about that in a little bit. So the full circumference here, if I would go all the way around this circle, that would be 24 pi. Right? But I'm not going all the way around. I'm going 45 degrees out of the total 360. Reduce that fraction. Your calculator can do that. If you can't, but you should know how to reduce a fraction. That actually reduces to 1/8. So I'm going 1/8 of the way. The whole way is 24 pi. If I multiply those together, I get 3 pi. 24 pi divided by 8 is 3 pi. That is how I want to write my answer. 3 pi units. That is how you do that in terms of pi. If the radius were reduced to 6 centimeters, the measure of the arc would stay the same. It would still be 45 degrees, but the length would change, and I'll show you what it looks like. So you're still doing 45 over 360, but now the circumference would be 2 pi times 6. So it'd be 1/8 times 12 pi, which would give me 12 pi over 8. And again, I got to reduce. 12 and 8 reduces to 3 over 2. So it'd be 3 pi over 2 units. So you see how the length changes, but the measure of the arc did not. And that's all due to the length of the radius. One more problem. I know it's a long video. One more problem here and we'll be done. All right, a lot of you are going to jump in and say, oh, it's AB, so 80 over 360 times, and then do your circumference part. Look at what the question's asking. It says find the measure of arc BCA. So BCA. What's the measure of that arc? Well, it's a major arc. I only know the 80. I'm doing everything but the 80. So 360 minus 80 is 280. So I got 280 divided by 360 times the circumference. So 2 pi. The radius is 5. So now I just got to reduce that fraction. That's 28 over 36, which 4 goes into both of those. So 7 divided by 9 times 10 pi. That's kind of disgusting, but that's okay. 10 pi over 1, so it's 70 pi over 9. Can I reduce 70 and 9 at all? I cannot. So that's the final answer, 70 pi over 9 centimeters. Get used to ugly answers like that because you're going to see them. All right, that's the end of this unit. We're going to move into area with the next lesson.